Hi everyone, my name is Welly from Education Delivery Team Palo Alto Networks. Today we are going to talk about networking topologies and standards. The main topics that we will cover on this presentation are the network topologies that is used on old legacy and modern computer networks, the difference on signaling, what is baseband versus broadband, and we will try to understand on high-level view what is LAN, WAN, and VPN technologies. And finally, we will briefly run through the standard specifications on Ethernet, token ring, wireless XDSL, and cable aka DOCSIS. So what is network topology? The topology is the network architecture used to interconnect the networking equipment. It will give the layout or arrangements of how the elements are being connected. As we have seen as today, legacy networks still exist and use old topologies such as ring and bus. And the modern networks, on the other hand, will use more common architecture like star and wireless topology. Start with the token ring. In this topology, we have a concept of token that is placed in the data channel and circulating around the ring. When the user wants to transmit the data, the node needs to wait until it has control over the token. And this technique is called the token passing based on IEEE 802.5. The token ring now become a legacy and is being replaced majorly by the Ethernet technology. Another legacy topology is bus. In bus topology, all the data traffic will be transmitted over a common coaxial cabling. When all networking devices will see there is a transmission, for example, from node 1 to node 2, and they need to wait the transmissions until it's complete before can start their own transmissions. If one of the data is placed on the network at the same time, the collisions will be happening and the data need to be retransmitted again. Bus topology are seldom used in modern computer networks. For star topology, this is the most common networking topology in today's network. The media that is being used is the twisted pair cable with modular plugs to connect computers and networking devices. And at the center of this star network is the networking devices called a switch or a hub. We will have another brief discussion about this. For example, if we're going to use a hub, the hub is going to broadcast the data traffic to all networking devices that interconnected in the star network. And if we're going to use a switch, the data from one node to the other node will be transmitted directly to the destination. So the switch is understanding about the broadcast domain. What happened next? We'll have a wireless network that now become more and more the network of choice in the environment, such as the home, small offices, and public places. So being able to connect to the network without a wire is very convenient, and the cost is much lower because they don't need to build a cable and wiring it to the LAN points. So mobility will provide flexibility. So fundamentally, the wireless LAN topology can be an ad hoc, where the wireless client communicate directly with each other, and the enhancement of the wireless network is using the access point that will interconnect the data from wireless LAN to the wired network. Finally, we have a mesh topology where all networking devices are directly connected to each other. This provides the full redundancy in the network data paths. But it will increase the cost definitely, because additional data paths will increase the cabling, the networking hardware costs, and it will also add the complexity. We have two types of signaling methods that used to transmit of information over network media, the baseband and the broadband. The baseband transmission is using a digital signal over a wire. The transmissions can be a form of electrical pulses or light. The digital signal that is used in the baseband transmissions will occupy the entire bandwidth of the network media to transmit a single data signal. The communication is bidirectional, so the transmit and receive of the data can be done on the single cable. However, the sending and the receiving cannot occur on the same wire at the same time. By using a multiplexing, we can achieve to transmit multiple signals on a single cable, and the baseband is using TDM, time division multiplexing, which divides a channel into time slots. The key thing about the TDM, it doesn't change how baseband transmission works, only the way data is placed in the cable. Compared to baseband, the broadband uses the analog signals in the form of optical or electromagnetic waves over multiple transmission frequencies. For signals to be sent and received, the transmission media must be split into two channels. So alternatively, we can also use two cables, one to send and the other one to receive the transmissions. And the multiplexing technique that is used in the broadband is known as FDM, frequency division multiplexing, that allowing to create multiple channels on the broadband systems. So by using this technique, it will accommodate the traffic going in the different directions on the single media at the same time. For providing access to the service provider network, we need to have a device called a modem. This device acting as a combined functionality, modulator and demodulator. There are varieties and type of modem technologies. We have analog modem that will connect it to the PSTN public telephone network. And we also have a cable modem that is connecting to the DOCSIS TV network, and we also have an XDSL modem. The idea is the modem will convert the signal that is received from the service provider network so that can be accepted on the digital computer local area network. We also need to understand the transceiver, that is the converter required to plug or terminating the cable into the network interfaces on the routers and switches network device, because those network devices requires the optical interface for the optical electrical signal conversion. So we have the big one here. It is called as GBIC or Gigabit Interface Converter. This is a hot swappable transceiver that is used for transmitting and receiving the higher speed signals over the fiber optic lines. So they have two ports for the transmit and receiving functions. And to increase the port density, now the industry has been moving forward to use a mini GBIC, or we name it as a SFP, small form factor pluggable. So when we are choosing the converter that's going to be used, we need to put into the considerations what cable type that we're going to deploy. So maybe we want to use a multi-mode fiber or a single mode fiber to support a further distance. And we also need to take into considerations about the throughput that we're going to achieve and what is the network port that is capable to receiving it. So maybe we want to have an SFP type of 1 gig or 10G, SFP plus, or maybe QSFP for the 40 gig. Once we have the planning ready for the topologies, the cable, media, transceiver that is required, we're going to build the simple network for the local connections named as LAN, Local Area Network. As we can see that we have multiple PCs or laptops that being wired into the LAN point that connected to the switch device. So this would be copper cable, UTP Cat6 media, and RJ45 connector type. And the switch will have a backbone connections to another switch. So we can provide the connectivity to the local server farm that sit on premises. So potentially this may be the local web server, or maybe this is a local file sharing server. And we also can share the printers in the same network. And the switches also can be connected to the wireless LAN controller and the access points so that we can interlink between the wired and wireless endpoints on the same LAN. After the network built locally, the big enterprises network is going to grow and require to establish and expanding the area into the wider multiple geographic locations. For example, we have a headquarters in one country and maybe multiple branch office, small offices on the other countries. Some company also put the data center for the servers, storages, backup on the different area. So WAN, wide area network technology, will provide that requirement. And typically the service provider will provide an access by giving them the technologies such as point-to-point, or maybe MPLS, public sharing network, internet backbone connectivity, maybe still using the legacy old technologies such as the frame relay, serial PPP, and dial-up. Since the WAN is a public sharing common network between multiple customers and tenants that subscribe into it, there is a requirement usually for the enterprise to build the secure network on top of their WAN connectivity. This can be achieved by having a VPN, virtual private network technologies, that run the encryptions to secure the data traffic that's flowing between two locations. First, we have an IPsec point-to-point VPN that will require two devices to establish the secure tunnel. It can be between two firewalls device, or modern router to router, or maybe router to firewall. So the communications between these devices will be encrypted using the specific algorithm. The second VPN technologies that we have is the client VPN, or sometimes people name it as a remote VPN. This will establish the secure communications between endpoints such as laptop, PC, mobile devices to the networking devices firewall. This will be very useful for the teleworkers employees that work outside the office. So up next, we will run through the standards of Gigabit Ethernet 802.3z. And in this column, we're going to see the multiple types of gigabit standards with the speeds. Of course, everything is supported as 1000 Mbps or 1 gigabit per second. How far distance that it can be supported, what is the cable media that's being used, and what will be the connector type. Start with down at the bottom, 1000 base TX. This is running on the copper media, and the distance maximum only support for 100 meter. And the cable type is a category 5 or higher. So the cable looks like this, the UTP, unshielded twisted pair, and the connector is RJ45. Next is 1000 base CX, still running on the copper cable, but it support a lower distance, 25 meters only. But they're using a shielded copper cable, means that the quality for protection from the noise is better compared to the UTP type cable. And the connector that is used is a 9-pin shielded connector. For the 1000 base SX and 1000 base LX, this is a fiber media type cable. And the distance is very depending on the type of the cable itself, whether it is a multi-mode or the single mode. So if you see as a MM here, it is a multi-mode type of fiber with a micron diameter of 62.5 or 50 micron. So then the connector type that's being used is the SFP, the one that we saw in the transceiver slide, for the small factor pluggable for your routers and switches terminations. For the higher speed and throughput, we also have a 10 gigabit Ethernet standard 802.3ae. So we have 4 types of standards, starting with the 10G base T. This is a copper type media specifications. The distance that's supported up to 100 meter or 55 meter depending on the category cable that you are using. Either it's category 6A or category 6 only. And we can either running on unshielded twisted pair or a shielded twisted pair. The connector type is a RJ45 for the copper media 10G base T standards. And for the 10G base SR, LR, and ER, this is everything running on fiber media. And again, the distance is depending on what cable that we are using. Either it is a single mode or multi-mode. As we have seen that single mode will able to support a farther distance up to 40 kilometers if you're running on a 10G base ER, and 10 kilometer for the 10G base LR. And for the multi-mode, depending on the micron for the diameter of the cable itself, for the 50 micron can support up to 300 meter for the 10G base SR. All the connector types will be running on SFP Plus to support a 10G connections interface termination. Before we move on to the other standards, let's take a look what network device options that we can have when we are building the network. So we have NIC, Network Interface Controller, that is attached to the PCs, laptop or servers, and they have the unique address burned in based on the vendor manufacturer, and we name it as the MAC address, Media Access Control. This MAC address will be learned from your switch in order to make a decision to forward from one port to the other port. So the switch is going to build the MAC address table based on the devices that connecting to it. The repeater, this is the device that is going to amplify the signal from one port to the other port. So they don't have the capabilities to learn the MAC address. They just want to amplify the signal because of the length distance limitations on your copper media. The hub is aka multi-port repeater. Same thing is they don't learn the MAC address and they have a broadcast concept to forward the frame to all the ports that they have. Next we have a router. The router is more intelligent. They can learn the logical addressing IP protocol address that we put on top of the network card that we have, and they will share the knowledge by advertising the subnet and prefixes through the routing protocols. And we usually have the Wi-Fi router that will connect this to the modem provider network that we have in the home to provide the access to the network for the mobile devices or the laptop that we have. Lastly, we have the firewall. This is the security devices that's going to make decisions in order to forward or not to forward the packet based on certain criteria. Maybe based on the layer 3 addressing, or maybe based on more intelligent decisions, whether applications that you want to use or URL that you want to use, or maybe they can also make inspections whether any malicious activities happening on the transactions. Token ring 802.5 is the standard that is being published by the IEEE. Still exists for some legacy networks, and they have the concept of MAU, multi-station access unit, that will connect the PCs and devices in the ring fashions. So you will see there are ports for the incoming and the outgoing token passing in between this MAU. When the owner of the token is being received by one of the MAU, the device that is connecting to it can have permissions to forward the traffic. So the cable type that is used in this token ring is category 5, 6, and the termination is RJ45. The token ring network is deterministic, means that each node that connected to the ring network will be ensured to access for transmissions on a regular fixed time interval based on the token ownership. Again, this ring network has become a legacy and is being replaced majorly by the Ethernet technologies. So next, what we have is the wireless standards. Varies from 802.11a, B, G, N, and AC, spread across different frequency and speed. So the latest one we have in the market as of now is 802.11ac that can support up to 6.9 gigabit per second, and the range up to 175 plus feet, running on indoor environment. And what we can see as today, there are two types of topology that is supported in the wireless network, either ad hoc or infrastructures. For the ad hoc, there is no access point is involved. The communication between wireless equipment is direct, so it's point-to-point communications via the wireless adapter itself. For the infrastructure mode, you will need to have an access points that providing the service set identifier, so everybody need to log in and perform authentications, and you can also provide additional security to protect the wireless communications in between two devices. So this access point is being handled and controlled by the device named WLC, or wireless LAN controller, and those IP communications between access point to access point and wireless controller is connected via the other networking devices switches here. We also have the XDSS standards that is mainly provided by the PSTN telephone network from your telco that is currently have the existing cable via RG11 terminations to your modem, and your modem is going to transmit and demodulates the analog signals to the digital signals based on the frequency that they're providing, so they can splice this into multiple categories. So the categories is based on how big is the downstream, upstream that they can provide, and what will be the maximum distance limit that you want to achieve. You can also see here at the far right columns what will be the typical applications that is using this existing public network telephony that's provided by your telco. So down at the bottom, very high digital subscriber line. You can have up to 52.8 Mbps for downstream, and achieving a different distance limit 4,000 feet at 12.96 Mbps. Mainly used for the ATM networks, and it also can be used for the fiber to your neighborhood, right? ADSL is very common for providing the internet access for the home users, and usually what you can see here, right, the downstream will have much higher rate compared to the upstream rate. So because of that, the name is asymmetric, comparing to the symmetric DSL that can give you the same rate of uploading and the downloading activity from the devices. So I want you to just take a look of this table. So I hope you can get the better understanding about what is the DSL technologies that legacy from the telephony existing network of the telco provider. So finally, we have the standards of cable, or we name it as DOCSIS, Data over Cable Surface Interface Specifications. This is using the existing infrastructure from a TV network running on the coaxial media. So the idea, the TV network wants to also carry the internet data traffic. If that's the case, you need to have a DOCSIS modem that will terminate the coaxial TV network so that it can split the data for the TV channel and also for the internet channel, and it will terminate the data channel for your Wi-Fi router, providing the access for the PCs and the laptop connecting to it. At 2016, the DOCSIS versions is already upgraded to 3.1 by restructuring the channel specifications for these DOCSIS versions. You can see the downstream and upstream data rates is increasing very high. So you can get up to 10 gigabit per second for the downstream rate, and for upstream rate you can have up to 1 gigabit per second. So that's pretty much about it. You have a couple of options that we already learned from the PSTN. You can have ADSL. For DOCSIS, you can have CAT TV systems, and you can choose whatever that is being provided by the service provider near to your area. I believe this is based on the current existing investment infrastructure that is already been built, and you can choose wisely the technologies that can provide the internet access to your small office or home office. So I hope you enjoyed the presentations. Thank you very much.